In this video, we're testing every food-related science experiment, from this homemade lava lamp to our very own elephant toothpaste. Starting off with our first one, the Coke and Mentos experiment. I got myself a bin here to open up our Coke. Oh my goodness. All right, I got my Mentos right here. Let's go ahead and put that to the test. Oh my God. Oh my God. Okay, the reason this has that reaction is because Coke has tiny gas bubbles in there, and Mentos is not smooth. There is holes all around it, and it shoots up and apparently makes a mess. If you guys thought that experiment was cool, as the video goes on, it's only gonna get crazier and crazier. Now for our next experiment, we're gonna be making dancing popcorns. Check this out. Into an empty jar, going with some popcorn kernels. Then we're gonna fill the jar up with some water. Then I'm gonna add in some baking soda. And we're gonna give that a good mix. We're gonna go in with some vinegar. Oh, this is why you don't wanna fill it up all the way. Yeah, the carbon dioxide is basically like hugging the kernel, lifting it up, and then more carbon dioxide bubbles come around it, lift it back up. It's kind of neat. Our next experiment is gonna use carbon dioxide, but in a more interesting way. It's a DIY fire extinguisher. So basically what we wanna do is into a bottle, we're gonna add in some vinegar. Now we're gonna take a balloon, put it around another funnel, and pour in about a tablespoon of baking soda. So when you mix baking soda with vinegar, you basically make carbon dioxide, and that's what suffocates fire. We're gonna wrap this around our bottle carefully here. Make sure it's nice and secure here. You don't want this thing popping out, because right when you drop in the baking soda, you're basically gonna fill this thing up with carbon dioxide. Is this gonna explode? Go ahead and throw it into a long tube bottle. So we're just gonna release the carbon dioxide into the tube bottle, and then we're gonna pour this over, and it just suffocates your fire. Look at that. That is crazy how that worked. That is fun. I love this one. Next, we're gonna be doing the cocoa powder experiment. Basically, if you take a spoonful of cocoa powder and dip it into any liquid, I got some milk here, you see on the top, the liquid stays. But once you take a skewer and break that tension, that is so sick to watch. Cocoa powder has fat and it repels the water. It doesn't mix well, just like oil doesn't mix with water. This is such a fun experiment and it worked perfectly. Let's move on to the next. Next, we're doing the imploding can experiment. You need any can that you might have. Just empty out the liquid inside of the can, and into the can add water and fill it up about a quarter high. And if you have a gas stone, you wanna get a pan, turn on the flame on high, and just place your can right in the middle until the water starts boiling. We're gonna go ahead and put on our safety goggles, and in one swift motion, I'm gonna lift it and put it into some cold water. I am freaking out here. Oh! That worked. Because the air pressure outside is much stronger than the inside, it squishes the can inwards. And that's how we get the can implosion. Our next experiment is called the siphon experiment. All we're trying to do is very simple, is take this liquid into this cup using a straw, which is basically our siphoning tool. And the reason we have this cup here is because the water from this cup is gonna go to this cup, and then this cup to this cup. There's a lot of this cups. Take our straw, dip it all the way into the cup, and let that air be filled with the water. Hold one end, we're gonna flip it, and then we're gonna watch the siphoning happen. Look at that. This is sick. The water molecules are basically sticking together. As the water moves down, more water flows. The siphoning stops when the water has equalized, and that's all due to gravity. This was a fun experiment. I'm happy it worked. On to the next. Now we're gonna be doing the egg vacuum experiment. We're gonna take this egg and have it go through the bottle. Right now, it can't go through the bottle. You just try to squeeze it, you're gonna break the egg. Well, we're gonna use a little bit of science. Take some sort of piece of paper or newspaper, light this up, and throw this into the bottle, and then throw your egg right on top. Oh my goodness. And the reason that this happens is when you drop the burning paper into the bottle, it heats up the inside air, hot air expands, and some of it escapes out of the bottle. So it pulls the egg into the bottle to fill up the space. We've all played with bubbles, but have you ever played with a bouncing bubble? Regular bubbles is just water and soap, and when you go to bounce it, it breaks. And that's just because of how delicate it is. And we're gonna make this stronger. And to do it is really simple. You go in with 8 tablespoons of warm water, 4 tablespoons of sugar. This is very important. And in order to make our bubbles, I'm going in with about 2 tablespoons of dish soap. Now our bouncing bubble mixture is ready. So in order for this to work, you gotta put on a glove because you gotta make sure it lands somewhere soft or else it could pop. So we're gonna take this, here it goes. Watch this. Look how sick this is. So the reason this works is because sugar acts like a humectant, which retains moisture and makes your bubbles stronger. But you do have to wear a glove because your hand will pop it. Watch. Your hand will pop. All right, let's move on to our next experiment. The bicolor separation. Going in with a little bit of water. And then we're gonna fill the rest up with acetone straight into my bottle here. Ooh, that is a strong smell. All right, we're gonna give this a good shake to mix the acetone with the water. Now I'm gonna add in 4 drops of purple food coloring. So I'm gonna go 4 drops. 1, 2, 3, 4. Oh, that looks sick already. Okay, now to this, we're gonna go in with a ton of salt, and then we're gonna give this a good shake. And now all we have to do is sit and wait and watch that color separate. Oh my God, dye separates differently in each liquid. So the acetone pools one color, the water and salt pool another color. And that's why we have 2 separate colors, which is kind of neat. Look at that, so sick. Our next experiment is expanding marshmallows. All right, I'm gonna throw my Lucky Charms into a bowl here. But these are freeze-dried marshmallows. I'm not sure if it's gonna work. Now we're gonna toss this into the microwave for 18 seconds. Apparently, the internet says when you toss this into the microwave, there's small air bubbles inside of the marshmallow, so the heat makes it expand. Oh man. Oh, this didn't work. I mean, these are freeze-dried marshmallows. The regular marshmallows would have worked, but now we're stuck with hot Lucky Charms. Great. Now we're gonna be making homemade lava lamp with just a few ingredients. Into a jar, go in with regular vegetable oil. And to that, we're gonna add in some baking soda right down to the bottom, some vinegar, and some food coloring. I'm gonna go with green. And then to make this even cooler, I'm gonna put a light underneath it. And then we're just gonna gradually add in our vinegar and it'll sink to the bottom. Here we have a homemade lava lamp. That looks so crazy. Vinegar and baking soda create carbon dioxide and the oil just keeps everything separate. So we get homemade lava lamp. For our next experiment, we're making flying tea bags and it's really fun to do. So we're gonna take any tea bag that you might have here. You wanna remove that string and then you should be able to open up your tea bags and then just toss out the tea inside. You know, you can get really silly with it and draw something on it, right? I'm gonna go ahead and not draw anything and I'm gonna put the name James because I know there's a James watching this video. I like you, James. So I'll do another one. Then we're gonna go ahead and light up the top of the tea bag. And once it burns all the way down, it should start flying in the air. Oh, there it goes. Flying tea bag. That's so sick. Hot air is lighter than cool air. So when the tea bag burns, the hot air inside pushes the tea bag. Pretty neat. Now we're gonna be making homemade slime, and this thing is absolutely easy to make and really fun to do. Into about a half a cup of water, add in your favorite color. Ooh, I went a little dark there, but whatever. 1 cup of cornstarch, add in our water. Our slime is officially ready. Look at this. So when you touch it and you kind of add tension to it, but the moment you stop touching it, it just kind of melts in your hand, is because cornstarch doesn't really absorb water. It doesn't mix into water. So it kind of stays suspended there. If I go really hard with this, my finger won't go through. But if I just leave my finger here, it's gonna slip in. And that's exactly how quicksand works. It's non-Newtonian fluid. This was a fun one. For our next science experiment, we're making transparent potato chips. We're gonna take some potato, just add a couple of slits into that because we want the starch and flavor of the potato to come out. Drizzle some olive oil. Then we're gonna add in our flavors. I'm just gonna go in with some salt here and some rosemary. Mix everything together to get that flavor. Now we're just gonna toss this onto a baking sheet. And now we're just gonna toss this into a 350-degree oven for about 30 minutes. Now we're gonna be doing the runaway pepper experiment. We're gonna be adding some water into a bowl here, some black pepper. If you guys notice, that black pepper doesn't sink because of how light it is. But whenever you dip your finger into some dish soap and then put it in the water, something magical happens. All that pepper runs away. Water has surface tension on top. So when you break it, the pepper just kind of runs away because it's floating on top. It's pretty neat and it's kind of cool to see it in real life. For our next experiment, we're making popping liquid balls. And you could do this with any liquid that you want. We're gonna go into our blender with a whole bottle of Gatorade. And to that, I'm gonna be adding 2% of its weight in calcium lactate. This is a very important chemical to add into our liquid. We wanna blend this up so it incorporates with our liquid really well. And now we're gonna take a circle-shaped silicone mold and go ahead and pour in our liquid. And now I'm gonna just pop this in the freezer until it's completely frozen. After about 30 minutes, our potatoes are nice, soft, and caramelized. Now we're gonna toss these into a bowl. And to that, I got some hot water and make sure my potatoes are nice and submerged in here. And now I'm gonna cover this and let this sit for about 2 hours to extract all that flavor from the potato. Next, we're gonna be doing the transparent Coke experiment. All you have to do is take some Coca-Cola, throw a funnel on top, and then we're gonna fill the rest up with some milk. Close the cap, a nice little shake. And now we're just gonna let this sit. Coke is full of acid. Milk has protein in it. So when you mix the two together, they start reacting. The acid in the Coke attacks the protein in the milk and makes them clump together. These clumps are called curds, and they're kind of the beginning of cheese. And on top, you get clear Coke, and on the bottom, you basically get Coca-Cola cheese curds. And we have clear Coke here. That is fascinating, and don't make Coca-Cola cheese. We don't need that in this world. On to the next. Okay, our spheres are almost frozen. So now we gotta make our second mixture. We're just gonna go into a blender with some water. And to that, I'm gonna be adding in some sodium alginate. This is the chemical that kind of keeps it together. And then we're gonna blend this so the sodium alginate mixes in with the water. All right, now into a pot, I'm gonna add in this mixture. We're gonna heat up this mixture up to 130 degrees. The sodium alginate and calcium lactate, when mixed together, they like to stick to each other. It creates this membrane around it, and you kind of get popping liquid. Our Gatorade spheres are fully frozen now. I'm gonna throw that into my alginate mixture, give this a nice swirl, let it kind of heat up here and to create its membrane around the Gatorade. Gently lift it up, put this into a bowl, cold water, kind of looks like jellyfish. And here we have Gatorade bubble balls. You pop it, that is so sick. And this is why I love science, because you can do cool things like this. Let's chicken in our potatoes. All right, after about 2 hours of soaking, I'm gonna go ahead and run this water through a strainer straight into a pot. Save those potatoes for another recipe. 4 tablespoons of potato starch, and that's what's gonna kind of give us the gloopy, slimy texture that we need to make our chips. Once our mixture is nice and thick and a bit slimy, we're gonna go ahead and throw it onto a rubber mat here, spread it out fully here. And then we're gonna take my giant dehydrator, open that up, we're gonna slip this in, close it, and we're gonna let this run for 10 hours. So we'll come back to this one later. For our next experiment, we're doing the water vortex tornado, which is basically 2 C batteries and a cup of water. So apparently, all you have to do is put one battery on one end and another battery at the other end, and a vortex should happen here. Let's see. I don't see anything. Nothing's happening here. I've been sitting here for 20 minutes and we don't have a vortex. This one's debunked, it doesn't work. Next, we're gonna be doing the rainbow milk experiment. So all we need is some milk, and then we're gonna add in some food coloring. I'm gonna go in with some green, put any color you want, get creative here. Now, you wanna take a little bit of dish soap. You can use a Q-tip to grab this. I'm just using this little tool right here. And then just drop it right into the middle of the milk. This milk is made up of fat and water. And when you add in the food coloring, the fat holds it in its place. And what dish soap does is it breaks down fat and it pulls everything away, trying to clear out all the fat. And that's how you get that reaction. That's pretty cool. For our next food experiment is a bit dangerous, but we're gonna be dissolving this aluminum can. Now, if you didn't know, every Coca-Cola has a plastic lining on the inside of the aluminum can. And what we're gonna do is we're basically gonna remove all the aluminum and just expose the plastic so you can see right through to the Coca-Cola. And the reason it has a plastic lining inside the can is to prevent the liquid from interacting with the aluminum. So it's mainly meant for a protection layer. In order to get this science experiment started, we just have to go ahead and sand off that ink. Now into any pot that we have, we're gonna go in with some water, open up the lid, and you're gonna stick a stick through the bottom hole here so then it holds up when we put it into the water. But before we put our Coke in, we wanna go ahead and add crystal lye to our water. And basically what crystal lye is sodium hydroxide, which is a strong base that's gonna react with the aluminum. Our Coke is ready, but we gotta be safe. We gotta take out the big guns. If you're gonna do this experiment, do it outside. Don't do it in the kitchen like me.
Can you guys hear me? Okay, here we go. And once you put the bottle in, and as you guys can see, aluminum burning off.
And after 15 minutes, the aluminum can is completely dissolved. The plastic hasn't melted is because it is specifically engineered to be chemically resistant to both acid and bases. Pretty cool, I can't believe this one worked. And after about 10 hours, our potato starch has fully dehydrated. And then we just wanna break off into small pieces here and fry this up real quick to give it that crunch that we're looking for. This potato has starch molecules that stick together, and when they're spread out evenly and dried out, you kind of get this crunchy, crusty layer that you could go ahead and fry up and make transparent potato chips with. It's a bit more chewy than a regular potato chip for sure, but it still tastes amazing. I'm impressed. Next, we're gonna be doing the rubber egg experiment, which is basically getting an egg, adding some chemicals to it, and then you could bounce it and see through it. Really easy to do. Egg into a container and fill it with some vinegar. So the egg inside the vinegar is gonna start evaporating slowly because vinegar is an acid. And the outside of the egg is calcium carbonate. And when you mix it together, there's a chemical reaction, and that's where you see these bubbles. The outside layer of our egg is just like chalk. So if you put chalk into vinegar, you're gonna start seeing that fizzing happening, and the chalk will eventually disintegrate. We gotta wait 1 to 2 days for the shell around the egg to completely disintegrate. So while we wait for this for 1 to 2 days, let's start our next experiment, which is ghost egg. Basically, it's the same process, but for this one, we're gonna add the dye of the highlighter. We're gonna take the back portion of our highlighter and just pull out the dye in the highlighter, and we're gonna drop this into the vinegar. The dye of the highlighter is gonna get soaked into the egg, and when our eggshell has fully dissolved, we're gonna have ghost egg. So we got two going here, one regular and one ghost. Let's move on to our next experiment and we'll come back to this. For our next experiment, we're making hot Cheetos caviar. With a little science, we can make anything into caviar apparently. Into a pan, we're gonna go in with some water and bring this to a boil. Open up your Cheetos, or you can use any of your favorite chips that you like. And now we're just gonna let it steep in that water and let this go for about 10 minutes. Now into another pot with a strainer on top of that, I'm gonna go ahead and pour my liquid. We just wanna hold back anything we don't want from the chips. And once all that liquid has gone through, we're left with hot Cheeto goop. Now we're gonna need 1% of the weight of our liquid in sugar agar. It's gelatin-like powder made from seaweed. It works kind of like Jello, but it's stronger and it doesn't melt at room temperature. So I'm gonna go in with 7.23 grams. And then go ahead and pour that sugar agar right into your liquid. Back onto the heat and bring it to a boil for about 30 seconds. The base of our hot Cheeto caviar is officially ready. Now you need some really cold oil, and I'm gonna take my droplets and create my caviar balls. Oh, no way. Do you guys even realize what's happening right now? The hot Cheetos caviar balls, like come on. Agar plus liquid plus heat dissolves. Cold oil and tiny drops, it solidifies. This technique is called sophistication. Sophistication. Run this through a strainer to just pull back all that oil. And here we have it. Our caviar balls are officially ready. Bon appetit. That is weird. Now we're gonna be doing the black snake fire experiment, and it sounds cool if it works. Onto my plate, I got some fine sand here, a little divot on top. I'm gonna take some rubbing alcohol, and then I have sugar and baking soda mixed right here, and I'm gonna add just a little. I got the fire extinguisher in case anything goes wrong, and then we gotta light this up. The alcohol acts as the fuel to provide heat, and then the sugar undergoes decomposition when heated, breaking down to black carbon and water vapor. So that's how you get that snake formation, which is kind of sick. If you're gonna try this, be safe. That's awesome. I can't believe it worked. And after 24 hours, both our eggs are ready. Let's start with the regular egg. This thing is soft. Look at this. It's so bouncy. I can't believe the hard shell has completely disintegrated. And when I put a light behind the egg, you can see the yolk. All right, let's pop it open and see what it looks like. Oh, ooh, that egg smells like vinegar. Oh, woo. Now let's see how our ghost egg turned out. It looks the same, but the way you could tell if this is glow in the dark is black light. This is completely green. That looks crazy. All that highlighter dye has seeped into the egg. And so when you put black light against it, you get a glowing object. Oh, there's that. The entire egg is glowing. This was one of my favorite experiments. I can't believe it worked. Let's move on to the next. Next up is the lemon battery experiment. First, I'm gonna need 4 lemons, and then zinc and some copper. All right, every lemon has 1 zinc and 1 copper. Boom. I'm just kidding. Perfect. The zinc is the negative and the copper is the positive. Now we're gonna take our wires. We're gonna go from zinc to copper. Now that I have all my lemons connected, we're gonna take our alligator wired teeth and put them on each end here. Our alligator teeth is ready. I got my light bulb. And since we have a really tiny LED light and huge lights here, we're gonna go ahead and power down the lights. Perfect. Now let's connect this and see if it works. No way, we have light. This works is because when you connect the zinc and the copper into a lemon and then connect them through wires, the acid from the lemon kind of helps move that charge along, which then powers our tiny little light. Again, it's not the brightest light in the world, but it's sick that this actually works. That's sick. We have now finally made it to our elephant toothpaste experiment. And we've seen a lot of people do this, but there is a safer at-home option. So we're gonna be doing that. For this experiment, we're gonna need active dry yeast. And to a bowl, I'm going in with about half a cup of warm water. That's what's gonna help activate the yeast. And to the bowl, I'm adding 1 packet of active dry yeast. And we're gonna put this off to the side and let that activate. Now we're gonna take an empty plastic bottle and we're gonna add some dish soap to the bottom. Now I got myself some hydrogen peroxide, which you can find in any home. And to make this look even cooler, I'm gonna go in with a little bit of food coloring. I'm gonna go in with some red. And then give that a good swirl so the food coloring mixes in. The time has come where we pour in our yeast mixture into the bottle and we should get elephant toothpaste. Here we go. Here it comes. No way, this is sick. So when the yeast touches the hydrogen peroxide, it makes a ton of tiny oxygen bubbles very quickly. The dish soap traps the bubbles, turning them into thick foam, and that's how we get elephant toothpaste. This one was really exciting to do. Let me know which one was your favorite experiment, and I'll see you in the next one.